So in today's video we are going to start a quick revision of scalar and vector chapter. So we'll go with this PDF, but before we even start this one I wanted to give you a basic intro of scalar and vector. So I am starting with scalar. Wait. Scalar and vector. Okay, so first we are starting with scalar. So first thing, scalar, these are, before we even start you need to know what is physical quantity. So physical quantity, anything which can be measured is called as physical quantity. So in physical quantity the example could be length, mass, momentum, angular velocity, these all. Okay, so if we talk about scalar, these are the physical quantities. Okay, physical quantities, they are specifically, they have magnitude only. Why I'm just saying magnitude only, just because in vector you will find magnitude plus direction, that's why. So in this one you will see that they have particular unit as well. So they are written as magnitude is equal to number into unit. What does this mean? This simply means if I'm just writing magnitude, like for suppose 5 kg, so here number is 5 and kg is a unit. Okay, so like this we will write. So the specifically we don't have direction in this one. And if we talk about properties of a scalar, whereas first thing, scalar quantities can be positive, can be negative, and can be 0 too. And when we talk about other, these scalar quantities are denoted by specifically represented by ordinary letter. And what exactly are, for example, if we take mass is a scalar. So mass can be written as m. For suppose we take length, I'm just telling you that we can write this by ordinary letter L. We can take time, which is equal to t. Okay, and scalars, another very important point. Scalars are added, like scalar can be added, they can be subtracted, they can be divided, and they can be also multiplied. So this means scalar, scalar follow algebraic law as well. And these are added and subtracted when unit and dimensions are same. When we follow these algebraic rules, we need to make sure that one condition always agree. That condition is when we add or subtract, like this condition. So we need to make sure that magnitude plus magnitude and unit must be same. Okay, and scalars are equal. Scalars are equal when their magnitude and signs are same. Scalars become equal when sign are same. So I'm sure it's clear to you. This was about scalar. We are going with vector now. For scalar we have like very simple rules. These are the physical quantity, of course, physical quantities. And the main reason between scalar and vector is that they have magnitude plus direction, whereas in that scalar we only have magnitude. And in this one we have so many like representation. In vector we have representation. And what exactly representation is? which is like not very important to discuss, because in we'll continue with PDF, which I will tell you is that, well, here's our notes. We are going to discuss scalar and vector right now. Other things like representation of vector, analytical graphical representation, we'll discuss later on. Right now let's look into the examples of scalar and vector. So we have a scalar example, time. Time is the good example, even that remains same in every unit. So time, mass, temperature, speed, distance, pressure, energy, current, power, work, magnitude, these all are the scalar quantities. Whereas vector, force, magnitude, impulse, velocity, torque, weight, all are the vector quantities. So here it's also written a little comparison. All those physical quantities. For now, physical quantities, of course, I'm sure you know that anything quantities which can be measured, and physical quantity which can be measured, and yes, they require magnitude and unit and scalar, as I just told you. And all those physical quantities that require magnitude, unit plus direction, that's called as vector quantities, and they are expressed as a row head or their symbol. Okay, so I'm sure it's clear to you. This is like a basic intro. So thank you for watching. Bye bye.